Here we have an absolutely wonderful application problem, and this is, a lot of why ellipses are so important is because of whispering galleries and acoustics and things like that. Um, I love these types of problems because anything that you can draw a picture out on, it makes it so much, it just makes it stand out because, you can really see what they're talking about. So let's read through this the first time and then we'll see if we can come up with a picture. Jim, standing at one focus of a whispering gallery, is 6 feet from the nearest wall. His friend is standing at the other focus, 100 feet away. What is the length of this whispering gallery, and how high is its elliptical ceiling at the center? All right, we're going to use symmetry to our advantage here. I'm going to go ahead and draw in an X and a Y axis system, and I'm going to draw the top half of an ellipse. I know that's not beautiful, but that's okay, because the bottom part of the ellipse would be like underground if we were talking about this being a room, and that wouldn't make very much sense. So we're just looking at a semi-ellipse to be this whispering gallery. Okay, now they talk about Jim standing at one focus. So let's say here is our focus, which means we have another one over here somewhere. And Jim is going to be standing right here. So we have stick figure Jim and stick figure friend. Okay, Jim and his friend. Now I know that I don't draw very beautifully, and that's okay. It's just a matter of getting an idea of what it is that you're talking about. Okay, so Jim is standing at one focus that's 6 feet from the nearest wall. Okay, so if he's standing at the focus and it's 6 feet from the nearest wall, they're telling us that from the wall here to where Jim is 6 feet. Okay. Doesn't that mean because of symmetry there has to be 6 feet over here from the friend standing at the other focus to that wall? Absolutely. So his friend is standing at the other focus 100 feet away. So if his friend is standing 100 feet away from him, then that means there's 100 feet between them. Okay, what is the length of this whispering gallery? Well, then the entire length of this would have to be 100 plus 6 plus 6. So the length would have to be 112 feet long. Okay, that one wasn't so difficult, especially once we drew out a nice picture of it. Now the next part says, how high is its elliptical ceiling at the center? Okay, that one we may have to think about just a little bit longer. So if they want to know how high that elliptical center is, they want to know what this distance is. Well, the way we've drawn it in here, we've elongated it along the x direction, right? Let's go ahead and let's list out our a squared, b squared, c squared, a, b, and c, and just in case we need it here. And in this case we will, because we know that a is the distance from the center all the way out to the vertex. So wouldn't half of 100 be 50 here, and then another 6 would make a 56 units? Absolutely. So we know that a has to be 56, which means a squared, if you square that, you have to get 3136. Now c is the distance from the center to the foci. So that would have to be 50, which if you square that, you get 2500. Now remember, a squared minus b squared equals c squared. So that means b squared has to be 636, which means the square root of that would have to be 25.2. And since b is the distance from the center to the other side of the ellipse, that tells us that the height of the ceiling is 25.2 feet.